This is a video tutorial for Unit 2, Day 3. This is the homework, pages 4 and 5. So today in class we learned about periodic trends. There's 3 of them: ionization energy, electronegativity, and atomic radius. So check the notes on this website. If you were absent and you missed those notes, you need to copy them before you try the homework. But also, you need to make sure you have this periodic table. This periodic table has everything, all right? And you get to use this periodic table on your exam. You're going to get one just like this on different color paper that has configuration on one side and trends on the other. So you need to understand what these 3 things are and how to read this periodic table. So question 1 is telling you to use arrows to label them big or small to big, okay? So the biggest ionization energy, I'm going to look here. The biggest ionization energy would be this one. So I'm going to write IE, biggest ionization energy. So it gets small to big for ionization energy. I'm going to use a different color for electronegativity. Electronegativity gets biggest towards fluorine, is my most greedy electronegative atom. I get more electronegative as I get closer to fluorine. Let me grab another color for atomic radius. Remember, atomic radius is how much space you take up, and my biggest, fattest element would be France. Francium, fattest country in the world. No, just kidding, that's us. But still, francium, we pretend. It's the biggest one. It takes up the most space. It has the biggest radius. The biggest, remember, radius means big circle. So, the biggest radius. So there's my atomic radius. It gets bigger as I get closer to this. And this is exactly what y'all have right here. I'm just copying it over to show that I've really looked at it. Okay? So now it says to put them in order of increasing atomic radius. So this is a goofy thing to say, but we did number 2 in class, so let's look at number 3. The alligator eats the big number. Arr, arr, arr. So the alligator is eating the bigger number, the bigger number, the bigger number. So this should be biggest. This should be smallest. Alright? And again, I strongly recommend that you rip up 4 pieces of paper, 4 little pieces of paper, or in my case I've got 4 little stars to find them, so that you can keep track of what's what. I've got sulfur right here. I've got oxygen, so I'm going to put that on top of oxygen, is one of mine. I've got neon, and I've got aluminum. Okay? And it says to put it in order of increasing electronegativity, and that would be this one right here. Fluorine is my most electronegative. Let me move it just like this. Fluorine is. So which one's closest to fluorine? Well, oxygen shares a side with it, but so does neon. Now notice that the arrows are pointing towards fluorine, because you have to remember from class that the noble gases don't have electronegativity. Electronegativity is a measure of how much you want an electron. These guys already have their full octet. They have 8 valence electrons. They don't want electrons, so they are not electronegative. So a noble gas will always be the wimpiest. If you say, hey, neon, do you want an electron? It's going to be a no. I really don't. Okay? Fluorine wants electrons the most, so it's the most electronegative. And look, oxygen shares a side with it. So that means the oxygen of all of these, not counting neon, because we already used that one, is the most electronegative, the biggest electronegativity. After that, which one of these is next closest? That'd be sulfur. And then furthest away would be aluminum. So that would be low electronegativity, doesn't want any electrons, kind of wants electrons, super wants electrons. Okay, so low to high. Just like it says here, pointing as you get closer. Okay, the amount of attraction you have for your own electrons. That's not electronegativity, that's ionization energy. And that's just right from the notes. Okay, so how much do you like your own electrons? Alright, so we said that right here, helium has the highest ionization energy. Because if I say, hey, helium, can I have an electron? It says, heck no. I'm a noble gas. I'm not losing them. If I ask lithium, hey, lithium, can I have an electron? It's going to say, yes, please, because metals want to lose electrons. So these guys have low electronegativity. Metals want to lose electrons. Non-metals want to gain electrons. So they have a high attraction for their own electrons. Alright, so ionization energy increases like that. Alright, if we're looking down, let's see, 10. Why do elements in the same family, remember families look like this, groups, columns, or families on the periodic table. Why do they have similar reactivity? Okay, and that would be because everyone in this family, 17, the halogens right here, Everyone in this family wants to gain one more electron. So they're going to react to gain one. Everyone in this family is already happy with their octet. Everyone in this family wants to lose 2 electrons for their octet. Okay? It's because they have the same valence electrons that they're trying to fix for their octets. Alright, let's flip over to page 5. Page 5 is going to end up being very similar. Alright, and let's look at 13, because I know I didn't do 13 in class. ABC. Again, I'm going to pull out either 3 pieces of paper or 3 little stars to keep track of these. And let's look at electronegativity. Alright, so I've got lithium, carbon, and nitrogen. List them from low to high. So the alligator eats the bigger one, which means this is the biggest, this is the smallest. Please don't do them backwards. That means you'll get it backwards on the exam. You've got to learn the greater than sign. Okay, this is the less than, greater than sign, greater than. So anyways, here I've got it. And my periodic table shows me electronegativity increases towards the arrow. So small to big, I follow the arrow. I have to uncover it. Li, and then carbon, and then nitrogen. Alright, let's look at this one. Magnesium, potassium, and phosphorus. Okay, well, which one's furthest away from this? Right, we've got electronegativity gets bigger when we go like this. So it's easy to see that the one farthest away from fluorine would be this one, potassium. So magnesium, where did I get that from? Yeah, no, that's right, K. Potassium is the smallest electronegativity. Magnesium's right in the middle. Okay, and then phosphorus is the closest to fluorine. See right there, phosphorus is the closest to fluorine. So P, right there. Largest atomic radius, Al or B? Let's put them on there. Those are the 2 that they're asking me about for this one right here. Aluminum or bromine, which one has the largest atomic radius? Okay, well, let's look at my graph. Atomic radius increases towards big fat francium. So I get bigger as I come down, which means this one's smaller, this one's bigger. So it says circle the largest, that would be aluminum. Yeah, we're just reading the graph. Now these ones are very important for exam. This is pretty straightforward. You read a graph. Okay, if it gets bigger along the arrow, which one has a higher electronegativity? This one, because the arrow points towards the high one. That's very simple processing, and it's good that you know how to read this. But we also fully expect you to understand what it means, what each of them means. So this one says an atom of chlorine, and I'm going to find it here and put a star on it. Chlorine has a greater attraction to its own electrons compared to an atom of sodium, Na. That's because chlorine has such a high blank. Okay? Does chlorine have a high atomic radius? No, not really. It's far away from francium, so that's probably not it. Does it have a high electronegativity? Yes, it does, so maybe that's it. Does it have a high ionization energy? Yes, it does, so maybe that's it. Does it have a high Heisenberg uncertainty? That has nothing to do with this question, so that's not it. Okay? So either C or B could be right, because chlorine has a higher electronegativity and a higher ionization energy compared to sodium. So let's read the question again. Chlorine has a greater attraction to its own electrons. Okay? That means it doesn't want to give away its own stuff. It doesn't say it wants more electrons more, but attraction to your own electrons. We would expect you to remember and memorize that that is ionization energy. It does not want to lose electrons. That's what this means. This means it really wants to gain electrons. But this one's saying it does not want to lose electrons. Okay. Iodine and strontium. So iodine and strontium both have 5 energy levels because they're both in... Oh, I should probably put that on camera. My mistake. Iodine and strontium. Right here. I put them here. Iodine right here. And strontium right here. Both have 5 energy levels because they're both in period 5. Okay. However, iodine has more protons in its nucleus and is able to pull electrons in closer to the nucleus, giving it a smaller what than strontium. Okay? You should memorize that pulling electrons in close to the nucleus will give you a smaller circle. Okay? Smaller circle means smaller radius. Okay? So again, it says in the question, it pulls electrons in closer to the nucleus. giving it a smaller radius. Otherwise, you could look at this. This one right here, iodine, has a greater electronegativity and a greater ionization energy compared to strontium. The only thing that strontium has a bigger, or that iodine has a smaller of, is its atomic radius. Okay. And I want you to use that same kind of rationale to explain this. Explain what atomic radius, it's radium, I should say radius. Okay. Explain why potassium, right here, has a bigger radius than bromine right here. This is this exact same question. It's that same idea. Why does neon have a higher ionization energy? Remember, ionization energy says how much do you want to keep your electrons. So why does neon want to keep all 8 of its electrons? Why is that so important to it? And then, why does neon have a lower electronegativity than chlorine? So why doesn't chlorine want more electrons? So neon doesn't want to lose its electrons, but it also doesn't want to gain any more compared to chlorine. You have to say why. And look up the definition of these 3 things in order to answer those questions. And we're expecting 2 or more full sentences. Alright, we're going to start nuclear chemistry next time, so make sure you're keeping up on this. Come in for tutorials if you need more help.